Good morning, boys and girls. Welcome to week 3, day 3 of Cumberland at Home Summer Edition. I'm Mrs. Driggers, and I'm so excited to be working with you today on math. Today, we're going to find a number that is needed when we add it to another add-in to make 10. We will be using a number line. Mrs. Driggers will be modeling for you how to count on or count back to find that missing number. Are you ready? Let's begin. Over the last couple weeks, we have been working together to compose and decompose the number 10. Remember, when you compose, you are combining or putting together two parts. When you decompose, you start with that whole number of 10 and you separate it into two parts. The parts that are added together to make 10 are called add-ins. When you add together the add-ins, it's going to equal the whole number. Today, you will use a number line to either count on or count back to find the number that makes 10 when added to the given number. A number line is a math tool where you have a line with numbers placed in the correct position. You can count on, so you could start at like 5 and count on, or you can count backwards anywhere on the number line. Today's activity, flip over 7, we are going to use a number line to help us find the number that makes 10 when added to the given number. Let's get started. 3 plus something equals 10. So if I want to use my number line, this is my friend Tony, he's going to help us count on our number line or count back on our number line. Because if you remember earlier when we did a lesson about missing numbers or unknown add-ins, we learned that you can use subtraction to help you understand an unknown add-in problem. So I'm going to model for you how we can count on and count back using the number line. 3 plus something equals 10. So if I were to count on, I would want to start at 3, and I would want to count the number of jumps that I took until I landed on 10. Now remember, when you use a number line, you want to wait until you make your first jump before you say 1. You don't say 1 when you are starting on 3. You say 1 after you jump and land. 1, 2, 3, 4, 5, 6, 7. It took me, or I should say it took Tony 7 jumps to get to 10. If I wanted to use the counting back strategy on the number line, I would start at 10 and count back 3 and see where I landed. 1, 2, 3. Tony landed on 7. Did we get the same number when we counted on and when we counted back? We started at 3 and it took 7 jumps to get to 10. And we also started at 10 and jumped back 3 jumps and landed on 7. So 3 plus 7 equals 10. 3 plus 7 equals 10. I'm going to take my next card and I'm going to begin my equation. I read my equation, 8 plus something equals 10. Okay, so I want to use my number line to help me figure out what I need to add to the number 8 to make 10. Now, I can count backwards, starting at 10 because I know that that's what I'm making, and count backwards 8 and see where I land. Or I can start at 8 and count on to 10 and see how many jumps it takes me. So let's do both. Let's start at 8 and count on. Remember, don't say 1 until you take that first leap and land on your next number. 1, 2. How many jumps did it take me to get to the number 10? I can start at 10 and count backwards, and I'm going to count back 8 jumps because that's the number that I know in my equation. So you ready? 1, 2, 3, 4, 5, 6, 7, 8. I landed on 2. Was that the same number I got when I started at 8 and counted on to 10? Yes, it was. So I know I have to add 2. I need to add 2 to 8 to make 10. Tony's helping me out. 8 plus 2 equals 10. Read this equation with me. 1 plus something equals 10. I need to figure out what number I need to add to 1 to make 10. I can start at 1 and count on all the way up and stop at 10, count the number of jumps I take, or I can use the counting backward strategy and start at 10 and jump 1 less to see where I land. So let's start with counting on. If I start at 1, I want to count the number of jumps that I take to 10. Count with me. 1. Oh, did you catch Mrs. Drigger's mistake? That's right, I said 1 before I took my jump. Let me correct. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many jumps did it take Tony to get to 10? It took 9 jumps. If I were to count backwards and start at 10, I'm only going to jump backwards 1 space or 1 spot on my number line because that's the number in my equation that I have. That's the add-in or the part that we know. So start at 10 and jump and say 1. What number did I land on? 9. Is that the same number that I got when I started at 1 and counted on to 10? Absolutely. So let's check our numbers up here, and do I have a 9? I would take my 9 and I would put it in my equation. Now I'm going to read the equation all together. 1 plus 9 equals 10. Remember, we learned that equals means the same as. So if I read it like 1 plus 9 is the same as 10. When I combine 1 and 9 and put them together, they are going to make 10, and 10 is the same as 10, or 10 is equal to 10. Read this with me. 6 plus something equals 10. So I need to figure out what I'm going to add to 6 to make 10. So if I were to count on what number, where do I start on my number line? If I wanted to count on. So when you count on, remember the numbers are getting bigger. Do I want to start at 6 or do I want to start at 10? I want to start at 6 because I'm counting on to get to 10. If I were to count backwards, I'm starting at my whole number. In this case, it's 10, and I'm going to count backwards 6 jumps to see what number I land on. So let's start by counting backwards. Let's start at our whole number of 10 and take 6 jumps on our number line because that number 6 is coming from the number that we have in our equation, not the one that we don't know, but the one that we do know, and we want to see what number we land on. Are you ready? Do I say 1 right here? No, because I don't want to say 1 until I take my first jump. Ready? 1, 2, 3, 4, 5, 6. What number did I land on? 4. Very good. So if I were to use counting back, I would say 6 plus 4 equals 10. Now to check my thinking or to check my strategy, I'm going to check it with counting on. I can start at 6 and count the number of jumps I take until I get to 10. Ready? 1, 2, 3, 4. Did I get the same number? Yes, I did. Do I have a 4 up here? I do. So I'm going to take my 4 and now I'm going to read my equation. 6 plus 4 equals 10. So let's read our unknown add-in equation. Remember, add-ins are the two numbers that you add together to equal or make your whole number. When you have an unknown add-in, that means you don't know what that number is yet. And that's what our job is as a mathematician. We have to figure out what that unknown number is. Kind of like detectives. We have to solve the mystery of what is this number, okay? So right away, I'm already thinking, 4 plus something equals 10. And I'm kind of remembering that thing called flip-flop, that it doesn't matter what order the numbers come in, when they're added together, they're going to equal the same value. So we just had 6 plus 4 equals 10, and now I'm starting with 4. So as I've gotten stronger at building my math fluency, I'm starting to think, wait a minute, I know that 4 plus 6 then would equal 10. Now I see that I have a 6 up here, but I'm going to pretend that 6 is not there, okay? Because this is where I want to kind of have us challenge each other a little bit and think about, are there any numbers in this row up here that if I put these two numbers together, I add those two numbers together, they're going to help me make 6. Take a look for just a minute. Okay, so I asked you if there were any numbers in this row here that when you add them, right away I noticed 3 and 3. 3 and 3 are doubles. If I start at 3 and I add 3 more to it, I'm going to make 6. So 3, 1, 2, 3. So I can decompose, or I can break down 6, and I can have 3 plus 3. So imagine I didn't have that 6 to pick from, but I did have 2 3s. I can have what's called a 3 add-in equation. 4 plus 3 plus 3, right? Because the plus sign is telling me that I'm joining these add-ins or these parts. Okay, so if I wanted to add, if I wanted to use the counting on strategy, because that's the math tool we're using is our number line, I could start at 4. I could add 3. So I'm going to start at 4. I'm going to jump up 3 jumps. 1, 2, 3. I landed at 7. Okay, I'm not quite at 10, but I'm not done yet. Now I'm going to add 3 more. So now I'm going to jump 3 more times. 1, 2, 3. Did I land on 10? Absolutely. So 4 plus 3 plus 3 is equal to 10. Did you see any other numbers in this top row that we could use if we were to break down or decompose 6? If I didn't have, we're kind of imagining, if I did not have this 6 in this row, we used our 2 3s. Are there any other combinations of numbers that I could put together to make 6? So right away, my brain, when I saw the number 5, I thought to myself, wait, 5 is 1 less than 6. And then I noticed over here that I had a 1. So my brain thought, wait, if I don't have a 6, I can add 1 plus 5. And I could make this equation a 3 add-in. A 3 add-in means I'm adding 3 numbers together to equal the same value as 10. All right, so let's check. Let's use that counting on strategy. Okay, I'm going to start. Now, actually, now that I look at these 3 numbers, you want to start at the biggest number. Remember, because it doesn't matter the order that you add your numbers. You don't have to start at 4 and then add 1 and then add 5. When you use that counting on strategy, you can start at the biggest number and then add on the second biggest number and then add on the least biggest number. Okay, so if I wanted to start at 5, because it's my biggest number out of the 3 in my addition sentence, I'm going to start at 5 and I'm going to add 4. So to count on, I'm going to jump 4 jumps. 1, 2, 3, 4. And I landed on 9. Not quite at 10 yet, but I'm also not finished. Because I've added 5 and 4, I also have to add 1 more. So I'm going to do 1 more jump. 1, and I got to 10. So 4 plus 1 plus 5 equals 10. Okay, let's try this together. Read this equation with me. 5 plus something equals 10. So if I wanted to start at the number 10 and count backwards, I'm going to do how many jumps? 5 jumps, because that's the number in my equation. That's the part I know. So you ready? 1, 2, 3, 4, 5. Where did I land on my number line? Very good, I landed on 5. If I wanted to count on and start at 5, I want to count the number of jumps I take and stop when I get to the number 10. Ready? 1, 2, 3, 4, 5. Now, I know, did I get the same number? Yes, I did. I got to 5. And I'm looking up here, and I have 1, 2, 4, 3, 7, 8, 9. I don't see a card that has a 5 on it, but I wonder if there's any numbers in this top row that when I add them together or join them together, they can make the number 5. What do you think? Are there any numbers that I can put together that might make 5? Right away, I saw, and I'm just going to put a 5 here just to show you. I saw 4, and that made me think, wait, 4 is 1 less than 5. So if I were to decompose or break apart the number 5, I can break it into 4 and 1, which when you use that word "and" in math, you think of the addition symbol or joining them together, right? So 4 and 1, or 4 plus 1, equals 5. So when I took 5 and I broke it apart and separated it, I separated it into 2 parts, 4 and 1. So if I wanted to add the 4 and 1 up here, I now have an equation that says 5 plus 4 plus 1. So that's very similar to when we were adding 6 and 4, right? We had broken our 6 into 5 and 1. And you could start at 5, count on 4 jumps, and then add that 1 more to get to 10. Okay, so we have 4 and 1 is one of our pairs of numbers that we can put together to make 5. What about, do you see any other combinations of numbers up here that we could join together to make 5? I see 2 and 3. Now remember, 2 and means I'm adding. So I can add 2 plus 3. And my brain knows that 2 and 2, because they're doubles, 2 plus 2 makes 4. Well, 3 is 1 more than 2. So if 2 plus 2 makes 4, then 2 plus 3, being 1 more, would make 5. And I'm going to do 5 plus 2 plus 3 equals 10. Now to check my thinking, I can use my number line and count on. I'm going to start with 5 because 5 is my biggest number in this 3 add-in equation. And I'm going to jump, should I just jump 2? I could, but I notice that 3 is greater than 2. So because when we talk about the counting on strategy, we want to pick the biggest number, we want to start with 5, Then I'm gonna add on 3 because 3 is bigger than 2, and then I'll finish with adding 2 more. So I'm gonna start at 5, and I'm gonna jump on or count on my number line 3 jumps. 1, 2, 3. I landed on 8. I'm not finished because I still have to add 2 more. 2 more jumps would be 1, 2. Because 5 and plus 3 equals 8, and 8 plus 2 equals 10. Wow, boys and girls, I am so impressed in how much you have grown and improved in your math over the last few weeks. Keep up the great work, and I'll see you tomorrow. Bye.